Hi everyone. Today we're going to study area between the given curve, x-axis, and two vertical lines. Here we have a function y equals f of x, represented by this graph on the rectangular coordinate system. We have the x-axis and the y-axis. We have two vertical lines that passes through A and B respectively. Now we want this area here. The area A, bounded by the curve y equals f of x, x-axis, and the lines x equals A and x equals B, is this formula. Capital A equals the absolute value of the definite integral from A to B, f of x dx. Let us see example 1. Find the area bounded by the curve y equals x squared plus 3x, the x-axis, and the lines x equals 2 and x equals 4. First, let us write our formula for the area. Then, let us substitute the corresponding values. So we have A equals the absolute value of the definite integral from 2 to 4 of the function x squared plus 3x, then dx. Take note that the function is increasing on the interval 2, 4. Showing this, we can take our function down here. Then let us see this table of values. When x equals 2, y becomes 10. When x is 3, y is 18. When x is 4, y is 28. We considered here the values of x on the interval from 2 going to 4. Since values of y are increasing, we can proceed with our integration here. Evaluating the integral now, we have the x squared becomes x cubed over 3 plus the 3x is now 3 times x squared over 2. And this will be evaluated from 2 to 4. We have now this 4 cubed over 3 plus 3 times 4 squared over 2 minus 2 cubed over 3 plus 3 times 2 squared over 2. Simplifying the first group, we will get this 64 over 3 plus 48 over 2 minus the second group, which is now 8 over 3 plus 12 over 2. Simplifying this further, we will get the final answer, 110 over 3, which is equivalent to 36.66 square units. This is the area that we want. Showing the graph, we can see here that this is the graph of the function y equals x squared plus 3x. The two vertical lines in black are the x equals 2 and x equals 4. The area that is being described is this part. Example 2. Find the area bounded by the curve y equals x squared minus 6x plus 8, x-axis, and the lines x equals 0 and x equals 3. First, we write the area formula. Substituting the corresponding values, we will get this A equals the absolute value of the definite integral from 0 to 3. Our function x squared minus 6x plus 8, then dx. Take note that the value of the function changes from positive to negative on the interval from 0 to 3. To show this, we write our function and also the table of values. Considering the values of x on the given interval, starting when x equals 0, y is 8. When x is 1, y becomes 3. When x is 2, y is 0. When x is 3, y is negative 1. You see here that the values of y changes from positive to negative. And we have a value of y of 0 when x equals 2. So it means the graph touches x-axis when x equals 2. Further, it implies that the area is split into 2 at x equals 2. It means to say the total area here is equal to area sub 1 plus area sub 2. Showing this, we can have this a sub 1 to be the absolute value of the integral. Now look at the limits of integration. For area 1, we will have from 0 to 2. Plus, we will compute for the same area, but the limits of integration for A2 will be from 2 up to 3. Now, we're going to compute for the areas 1 and 2 respectively. Let's begin with area 1. Let's copy this area over here. Let us now evaluate the integral. The integral of x squared will be x cubed over 3 minus integral of 6x is 6 times x squared over 2 plus integral of 8 is 8x. This will be evaluated from 0 to 2. Simplifying further, we will get the middle term to be 3x squared. Now let us evaluate this expression with respect to the limits of integration. We will get now 2 cubed over 3 minus 3 times 2 squared plus 8 times 2 minus 0 cubed over 3 minus 3 times 0 squared plus 8 times 0. The second group here will come down to 0. We can simplify the first group and we will get the final answer for area 1 to be 6.67 square units. This value we will copy below area 1 in this formula. Then let us solve for area number 2. Let us copy this expression over here. Now let us integrate. We have now this x cubed over 3 minus 3x squared plus 8x to be evaluated with the limits of integration from 2 to 3. Evaluating further, we have now 3 cubed over 3 minus 3 times 3 squared plus 8 times 3 minus the second group, 2 cubed over 3 minus 3 times 2 squared plus 8 times 2. Simplifying the first group and the second group, we have now the first group to be simplified into 6. Then minus the second group is 6.67. We know that when we compute for the area, we will take the absolute value. 6 minus 6.67 is negative 0.67. Because of the absolute value, area sub 2 equals 0.67 square units. Take note that the negative sign in the computation here only means that the area is below the x-axis. Now let us copy this value below this area 2 on this formula on the left side. So the total area 6.67 plus 0.67, the total value will be 7.34 square units. This is our answer. This is the total area. Just to show the graph of this problem, we have this graph of the function. It's a parabola. Now the two vertical lines are these red lines, where x equals 0 is the first line. This is actually the y-axis. The other line is x equals 3, and it is here. Describing the area 1, it is in here. Now for area 2, we have this shaded area here. I hope you learned something from this video. See you again next time.